Hello Year 9, hope you're all doing well during the lockdown. Thank you to so many of you providing me feedback about these videos. I've put lots more questions and lots more opportunity to pause the video and write down notes this time. So if you have any more suggestions, please email me and I'll do what I can to make these better for you. So today's lesson then is called Stopping Cars and Reaction Times, and our objectives are I can define stopping distance, thinking distance and braking distance. I can explain factors that affect thinking distance, and I can describe an experiment to measure someone's reaction time. So for our starter, I've got two questions for you, and you're going to pause the video and you're going to write down the answers to these in your books. So when a moving vehicle suddenly brakes, it doesn't stop straight away. What happens? And it's the same if you're cycling too. When you pull on the brakes, the bike doesn't stop straight away. Why not? So pause the video and answer these in your books for me, please. Okay, so before we answer this, this is really important. It won't mean much to you right now, but it will do by the end of the lesson. So the total distance travelled to stop is called the stopping distance, and it's made up of two separate components. One of them is called the thinking distance, and the other one's called the braking distance. And we put this into an equation that says stopping distance equals thinking distance plus braking distance. So in your books, underneath your answers to the starter, if you could write this out, and the equation, if you can highlight it. I've highlighted mine in yellow, but if you highlight yours in whatever colour you've got, or put a big box around it, because this is super important. So pause the video now. Okay, so moving on then, let's see if we can answer our starter question using that equation and build up on our knowledge. So when someone walks out in front of a vehicle, the driver doesn't instantly press down on the brake. It's like when you ride a bike as well. If you ride a bike and you see something jump out in front of you, you don't instantly press that bike straight away. There's an element of thinking involved. So your eye is going to see the information. Your brain needs to process that, send a message down to your muscles in your legs, if you're in a car, or your hands or your arms if you're riding a bike, and then press the brakes. Okay, and all the while you are thinking about doing that, the car or the bike is travelling a distance, and this is called a thinking distance. Okay, so the thinking distance is the distance the vehicle travels between the driver seeing the danger and then acting on it, so pressing the brakes. So this is a distance, and most students talk about times in this. Please don't. The thinking distance is the distance the car travels whilst you are thinking about pressing the brakes. Okay, so if you pause the video, and that yellow box, if you write that into your books for me, please. Look at the braking distance then. So once the brakes have been pressed, the car or the bike, it doesn't stop immediately. We know that, right? It's common sense. So they're going to decelerate, and they will travel a distance as they are slowing down to a stop. And all the while you're braking, the vehicle is going to be travelling a distance. And this is what we call the braking distance. It's the distance the vehicle travels until it has stopped. Okay, so if you can pause the video, and in that yellow box, if you can write that into your books for me, please. So in a few years' time, you're probably going to want to learn how to drive. And on your theory elements of your driving, you're going to have a table that looks something like this. The blue kind of shapes represent the thinking distance, and the red arrows represent the braking distance. If we look at 70 miles per hour, you can see that the thinking distance is 21 meters. That means if you travel at 70 miles per hour and you see an obstacle in front of you, to think about it, send that message down to your muscles, your car is going to travel 21 meters. And then once you've pressed the brakes, the car will slowly come to a stop, and that will be another 75 meters. So altogether 96 meters to stop the car. So that's a really long way. You all know what 100 meters looks like. Okay, you all do PE, you've all been out on the field. Yeah, it's almost 100 meters to stop the car if it travels at 70 miles per hour. If you look at 30 miles per hour, obviously going much slower, but the thinking distance is still 9 meters. That's about the length of one of the largest classrooms we've got at Frome. So just to think about pressing the brakes, the car will travel 9 metres and then a further 14 metres to stop the car. So you think about your big science classrooms, think about the longest length. It's probably 3 or 4 times the length of the classroom just to stop the car at 30 miles per hour. It's a long, long way. So here are 2 questions for you to do in your books. Okay, question 1, if you double your speed, what happens to the thinking distance? And is this also true for the braking distance? So if you pause the video and answer both those questions into your books, please. Okay, let's have a look at some answers then. So if you double your speed, what happens to the thinking distance? Well, let's have a look at 20 miles per hour. The blue thinking distance is 6 meters. And at 40 miles per hour, so we've gone twice the speed, the thinking distance is 12 meters. So yes, it does double. Okay, so if you double your speed, you double the thinking distance. If you triple your speed, you triple your thinking distance. And it's what we call a linear relationship. Is this true for braking distance? Well, 20 miles per hour, the red braking distance is 6 meters. 40 miles per hour, the red braking distance is 24 meters. So it's what we call an exponential relationship. It goes up more and more and more. It doesn't double. In fact, it's doubled. It's gone up by 4 times. So no, it's not true. Well done if you got both those right. If you did, give them a tick. If not, just add in your answers to your questions now. Okay, so there are lots of different factors that affect the thinking distance. So let's look at 3. These are the 3 most important ones. And these images represent that. So if you're tired, you're under the influence of a depressant drug, or been drinking alcohol, or you're distracted, all of these factors are going to increase the thinking distance. They make the brain work slower. Okay, so that message from your eyes to your brain to your muscle is going to happen slower, but that's going to increase the thinking distance that the vehicle goes. And that's the important bit. Right now, don't worry about reaction times and everything. This is all about how far the car travels. So the thinking distance the car travels is going to increase. And conversely, if we are drinking stimulants like had a cup of coffee or a Red Bull, fully rested, wide awake, have no distractions in the car, then all these things are going to reduce the thinking distance. They will make your reaction time faster, I agree, but the thinking distance of the car travelling is going to be less. So can you please pause the video, and the white boxes, if you write those into your books for me, please. Okay, the next part is quite a tricky concept. If a driver goes at 20 miles per hour, the time to react is going to be X amount of time. If they travel at 60 miles per hour, the time to react is also going to be the same, right? It's going to be the same. But the distances, the thinking distances are going to change. The faster you travel, the further the thinking distance. Because you're traveling faster, the car is going to go further. But the time to think about it is going to be the same. If you want to write that part down, you're more than welcome to. Okay, so we've just done thinking distance. Let's have a look at braking distance. So the thinking distance was all about you. It's all about your brain and your reaction times and all about you as a person. The braking distance is all about the car and the road. So if you drive on icy or wet roads, there's going to be less friction between the tyres and the road, so the car is going to travel further, it's going to slide, so the braking distance is going to increase. If you have bold tyres or poor brakes, again there's less friction, so the car is going to travel further. And if you drive too fast, that's going to increase the braking distance too. So the faster you go, the further the car travels whilst you are braking. And again, conversely, if we drive on good dry roads, have brand new brakes, brand new tyres, we drive slower, all of these are going to reduce the distance the car travels whilst the brakes are being applied. So it's going to reduce the braking distance. If you could pause the video and copy the white boxes into your books, please. Okay, so here we've got a bus and a car, both travelling at 30 miles per hour. And in your exam, you're going to get lots of tables and graphs that you need to be able to interpret. So we're going to have a look at some graphs now. So using that table, which has got the furthest stopping distance? So bus and car, both at 30 miles an hour. Which one's got the furthest stopping distance? So if you pause the video and answer that question in your books, please. Okay, let's look at the answer then. So 30 miles an hour, the car is the yellow bar and the bus is the orange bar. 30 miles per hour, the yellow bar is about 55, 60 feet and the orange bus is about 75, 80 feet, something like that. So if you said that the bus would travel further, well done, tick your work because you've got that right. But why is this? Well, a bus has a much, much greater mass. And we looked at that in an earlier lesson when we looked at mass versus weight. So because it's got a much bigger mass, a huger, larger amount of force is going to be needed to slow it down. And because a greater force needs to occur, it will travel further. So the braking distance will increase. That means if you're driving a car and you've just got the driver in the car, compared to 4 people in a car, then the one person in the car has a shorter braking distance or overall stopping distance than if it's got multiple passengers in the car. So if you want to write that bit down, you're more than welcome to. So it's really important then that drivers drive safely around Frome and they know the limits of their cars. So what can drivers do? So here are some images that might help. You can write down in your books how drivers can drive safely around Frome. That'd be really good. You might want to just bullet point 2 or 3 ideas. Okay, so let's have a look at some answers there. Slow down. Okay, especially when it's wet or windy, when the road conditions are really bad, just slow down. Your overall stopping distance is going to reduce if you're travelling much slower. If you drive to the appropriate speed limits, so outside of school we say 20 is plenty, you'll see 20 miles per hour everywhere, then your stopping distance is going to be quite short. But if you were to drive at 70 miles per hour, we know the overall stopping distance is 96 metres. Well, that's just ridiculous. You don't want a car that takes 96 metres to stop driving at that sort of speeds around a school. There's so many students walking around and adults walking around, it's going to be crazy. And also you keep a satisfactory distance from the car in front of you. So they kind of say 3-second rule. If you can be 3 seconds away from the car in front of you, then that gives you time to react. So you're not going to hit the car in front of you. So looking at the reaction speeds, you can have a go at this yourself. So when drivers are more alert, they improve their thinking distance. Okay, so if you've had a stimulant like Red Bull or caffeine, as we looked at earlier, you're going to be much more alert and you're going to have much faster reaction times. And here's a little game run by the BBC. And you can click on the link or look at the PowerPoint afterwards and click on it, or you can just type it into Google. You'll come to it. And there's a little game, the sheep run across and you've got to shoot a dart at them. But it gives you your reaction speed and you'll get answers that look like this. So my first attempt, my average was 0.2566 seconds and the second attempt 0.362 seconds. So looking at those 2 sets of answers, which one do you think I did this game when I was more alert? And which one do you think I did when I was really tired? Well, if you said the one on the left was the one that I did it when I was wide awake, well done. It's a much shorter time, it's much quicker. The one on the right is much slower. So that's the time when I was doing it, when I was very sleepy. I think it was about 11 o'clock at night. I was very sleepy when I did that one. Have a go. See if you can beat my fastest time. So let's go back to the graphs then. So here's a graph here, the effect of caffeine on reaction time. So caffeine is a stimulant and it's found inside things like coffee and energy drinks. And a similar graph is looking at how often people drink caffeine. So in your books, see if you can answer, what do these graphs suggest? What do these graphs show? Okay, let's have a look at an answer then. So the graph on the left, if you have caffeine, which is the blue bar, you can see your reactions, your average mean reaction time is much faster. So that would suggest that caffeine makes your reaction times much quicker. The graph on the right shows that if you have 2 to 4 cups of coffee or 2 to 4 shots of caffeine, then you're going to have a much faster reaction time. But if you have too little or too much, it can actually have a negative effect. Okay, so the orange bar shows if you have 4 or more cups of coffee or any energy drinks, it actually decreases your reaction time. So too much of a good thing, you probably heard that, isn't always good for you, and it applies with caffeine. So there's an optimum 2 to 4 times a day. 2 to 4 drinks of coffee, 2 to 4 drinks of Red Bull. That's what we call optimum. That will have you a good effect on your reaction time. So the RAC compiled these results too. So you've got texting, smoking cannabis, drinking alcohol, being hands-free, or holding a handheld device. And up the y-axis, impairment to the reaction times. This means how does it affect the reaction time, and it's as a percentage. So have a look at those and see if you can answer the question, what do these tell us in your books? If you pause the video now. Okay, so answers them. Well, hopefully you said that all of these have an effect on the reaction time. They do slow down the reaction time. But a handheld device like a mobile phone, because you're constantly flitting your eyes, to the phone and then up to the windscreen, looking at the road and back to your mobile phone, this actually affects your reaction time more than anything else. And so does texting, which is why you can see why the police say that you shouldn't be using a mobile phone whilst you're driving, because it has the biggest effect on slowing down your reaction time. So that's going to be a much bigger effect on your thinking distance. It's going to make your thinking distance much, much further. Alcohol and cannabis affect it too, as we would expect, because they're both depressants. So that comes to the end of today's lesson then. So you've got task 1, 2, 3, 4 and 5 to do. So lots of you emailed me and said that you wanted an actual sheet of questions to do. So this is your sheet of questions, and I've kind of written them in a different way this time for you. So task 1, this is an exam question. Define the following terms: stopping distance, thinking distance, braking distance. So if you write your answers in your book for task 1. Task 2, again, it's a similar sort of exam question, but I've just used Frome as my example. Where in Frome is 30 miles per hour? So you might think about, I've seen a 30 sign somewhere on the road. Whereabouts is that? So if a driver was to drive at 50 miles per hour, how is that going to affect a thinking and braking distance? So you need to write perhaps 3 or 4 sentences. It's like a longer style answer, 3 or 4 sentences answering that question. Task 3, again, it's a past exam question. Why are roads outside schools limited to 20 miles per hour? We have discussed that earlier on in the video, so you should be able to answer that one. Task 4, now this one is a fun task. Design your own experiment to test someone's reaction speeds. So what you need to do is write a step-by-step method showing how you could do this. So step 1, do this, step 2, do this, step 3, do this. So how could you test someone's reaction speeds? You've done the game with the sheep and the darts, well, you're going to do that. It is really, really good fun. So what experiment could you do? And we don't want to harm any animals in this, so please no shooting real sheep, not good. And then task 5, as always, this is your revision. Some students commented, what's the point of task 5? Well, this is the only time you're going to learn this. So if you get through year 9, year 10, and the end of year 11, you've got your exams, you're going to have to either relearn all this all over again, or you're going to rely on your revision cards or your revision books to help you. So by making these revision postcards, it's going to help you because it's going to save you time making resources in the future, and also you're able to look at something that's short and you're able to constantly read over it, and it goes into your long-term memory much, much faster. So summarise this lesson, keywords and definitions in the margin, summary, factors that affect stopping and braking distance and thinking distance, and at the bottom, anything you're unsure of. And again, as always, just email your teacher if you're unsure about anything, and we'll go through it with you. So thank you very much, and I hope you tune in next time, and I hope you enjoyed today's lesson. Take care, everybody.